Welcome everybody to this session. It's IBM Spectrum Virtualize for Public Cloud. We're going to talk about hybrid cloud use cases, real world solutions, and I'm really excited today to be joined by the folks from the ATS group, who are Tim Connolly, principals of the ATS group, Dave Hamilton, VP of Strategy, and Bill Asimos, VP of Sales. And so we've got a great agenda. And Tim, why don't I turn it over to you to take us through the agenda and kick it off?
Sounds good, Michelle. Thank you very much, and welcome everybody. Thanks for joining us. We're going to give you an overview of Spectrum Virtualize for Public Cloud. What is it? How does it work? Tell you a little bit about the ATS group. We'll get into some customer use cases or use cases in general, just so you have an idea on where this solution can fit. Then we'll get into 4 or 5 real-world customer use cases. We'll talk about measuring workloads, and then a few technical things we've done in the past. Want to bring that to this session as well, where we'll show you about data reduction, easy tier, how that applies to this solution in AWS. And then we'll give you a flavor on some pricing scenarios, just so you have an idea on what the solution may cost you based on certain capacity points that we've done. And then we'll have a Q&A at the end as well.
Okay.
Okay, Michelle.
All right, so I'm going to just take you briefly through Spectrum Virtualize for Public Cloud. I think some of you may be familiar with this offering already from IBM, but just to refresh, so Spectrum Virtualize is the software that runs on premises in our IBM StoreWeb family, our flash system family, and SVC. And what we brought to the market a few years ago is IBM Spectrum Virtualize for Public Cloud. This is a separate product, separate licensing terms. It runs on any supported cloud infrastructure, that's IBM Cloud and AWS today. We're working on others to come in the future. And technically, the solution, Spectrum Virtualize, running on public cloud infrastructure, which means public cloud servers or VMs, it's largely based on Spectrum Virtualize. It's mostly all the same code, but it has been adapted to run on public cloud infrastructure. So things like clustering and failover are a bit different because of the way that the infrastructure is engineered. In a hyperscaler, for example, there are no fiber channel components. Also, it's a shared network infrastructure. The backend virtualization is a bit different, and of course, the deployment is different in the cloud. So, other than that, though, it basically works the same as what you might expect on-prem with an SVC. And speaking of SVC, if you do have SVC or VSC, the capacity that you might have, that spare capacity, or if you're purchasing more capacity, there's a way that you can now use that also for Spectrum Virtualize for Public Cloud. So it gives you the ability to essentially extend your SVC licensing to the cloud. Okay, next page, Tim. So the features that are provided in Spectrum Virtualize for Public Cloud are all-inclusive. In other words, the license includes all the functions and features that you've come to expect on premises, from volume management to DR and HA. These are very important features if you're trying to set up any kind of hybrid cloud capability between on-prem and one of the public clouds. All of the Metro Mirror, Global Mirror with change volumes are supported. We do recommend Global Mirror with change volumes if you're any distance from the public cloud data center. and then all the copy services are included. And on AWS, which we're going to focus on in this session, is on AWS Marketplace, and I'll show you that. We can support up to 20 backend EBS volumes on a cluster in AWS. The volumes can be up to 16 terabytes, and so you get 320 terabytes of actual capacity per cluster. There are 3 types of EC2 instances. I think Tim's going to get into that, and any available EBS tier that you want to purchase pretty much is supported. It is worldwide. It's supported across all the AWS data centers around the world and in North America, including AWS GovCloud. And we do have a whitelisted trial available, which means that if you'd like to try this out yourself in your own AWS, AWS account, you can do that. Okay, so let's go to the next slide. And just to talk about how this gets launched. So purchase the license from IBM. It can be purchased through Passport Advantage or on with the hardware through eConfig. Once the license is available to you, you simply go onto AWS Marketplace and look for Spectrum Virtualize for Public Cloud. You'll see a landing page, and there's some options to fill in to select your EC2 instance and your EBS storage. And you can always add more EBS storage after you configure your initial cluster. And it deploys like in 15 minutes in an existing VPC, so it's very quick. And when you go to AWS Marketplace, you'll see the landing page, which I think is on the next slide. And it looks like this. So that's really it. I just want to start this off by a brief introduction of the product, and now I'll turn it back to Tim to get into the details of the use cases.
Okay, great. Thank you very much, Michelle. So I'll give you a quick overview on ATS so you have an idea on where the heck we came from. So ATS is a consulting company by trade. We don't sell anything. We do a bunch of work around architecture, implementations. We've been working with Spectrum Virtualize since it hit the marketplace like 13 years ago. Very much integrated in that with many, many customers. We've also, this solution is actually really cool for us because we're able to take our on-prem storage expertise and marry that up with our cloud computing, which you can see in the bottom left. So we have an AWS practice. So we're able to see both sides of the fence from an expertise perspective. So IBM asked us to join the beta program, which we'll talk about in a few minutes. So we do a bunch of things around compute, storage, data protection, managed services. We could talk about that a little bit towards the tail end of this. And some of you may know that we also created Galileo Performance Explorer in our performance suite. So how do we get here? So we're actively engaged in the IBM beta program, have been for, probably over 10 years now, along the storage and power footprints. So beginning of last year, April of 19, we were in the SV for Public Cloud beta program. So we were able to take our expertise from the on-prem Virtualize and the AWS practice and basically configure our own Spectrum Virtualize for Public Cloud and our on-prem solution. So as we go through this and you see the various flavors and capabilities, these are all things that we did in the beta program with IBM. So it's a really cool thing for us. At that time, we were running with an SVC, SV1 nodes and a Flash 900 for that particular beta program. We were also in the follow-on beta program in the fall of last year or spring of this year, where it extended the volumes Michelle just mentioned. It went from 16 to 20 volumes, so enlarge your capacity from a cluster, 256 terabytes to 324 terabytes. Also now you can go up to a 4-node, quote unquote, SVC cluster or store-wise cluster. And then here at the bottom, we're actively engaged in the latest beta program for Spectrum Virtualize. Some of the key things we're working on in that is 3-site hyperswap and DRAID 1 functionality that's available in the beta program. I believe it's going GA in December of this year. And with that, we're using 3 7200s that are in our lab that you can't quite see in a picture on the left there. But we have a lab here in Malvern, Pennsylvania, where all this data's equipment's housed. Allows us to do all this great testing. So a lot of the technology things we're about to show you were all done right in our lab out to AWS. All right, so let's talk about use cases from a high-level perspective. So you have really 4 distinct groups of use cases. So I can extend my on-prem to multi-cloud. What does that really mean? That means I can temporarily move data to the cloud, or I can permanently migrate data to the cloud. It could be your data, your containers, VMs, from one cloud to another, from on-prem to the cloud. So it's the ability to extend your on-prem to a hybrid multi-cloud, incorporating at this point in time AWS or IBM cloud. Continuity is big for everybody for disaster recovery or just business continuity in general. So in this case, you're able to do DR, which we call replication within Spectrum Virtualize. It could be sync or async out to the cloud. If you want to replicate something from on-prem to the cloud, and I have a use case for you, which I'll explain in a few minutes here. Data protection. If I'm in, say, AWS and I want to do data protection, I can actually then create snapshots and send them over to the IBM cloud as my quote-unquote second data center, so to speak. Third and last, again, we'll show you some of this, is block storage optimization. So on-prem, we've known about this for years and years and years, where I can do thin provisioning, compression, deduplication. These features and function are now available in Spectrum Virtualize in the cloud, whereas native AWS, there's no such a thing as thin provisioning, compression, and whatnot. So we'll show you some examples of how we've done that, and we'll give you some idea on what your savings may be based on some real-world scenarios that we've gone through. All right, so what does this actually look like? I'm a picture person, so this is always beneficial to me. So here is on the left-hand side would be your on-premise solution. So this depicts a 2-node SVC cluster. As Michelle mentioned, it could be any Spectrum Virtualized family member. Your hosts are connected via fiber channel or iSCSI. And then on the back end, in this particular case with an SVC, I'll have some sort of fiber channel or iSCSI storage connected to this 2-node SVC cluster or any store-wise footprint you may have on-prem. Then you simply do IP replication to AWS, and that depicts a 2-node SVC cluster in AWS, and I can attach EC2 instances to that with Amazon EBS storage behind the covers. And we'll talk about the various levels and types of storage, why you may select one over the other, and how Spectrum Virtualize can enhance and decrease your costs based on the footprints that you can accept out there. All right, business continuity. So this would be taking your on-prem IP, replicating it to AWS, and having your disaster recovery in the cloud. So there you can see depicted your EC2 instances connected to the Spectrum Virtualize. So if you had a failure on-prem, you can simply have your business continuity stood up in the cloud with applications on your EC2 instances simply connected to Spectrum Virtualize, and away you go. Again, that could be async or sync depending on your distance from the cloud. Again, if you have any questions as we go along, you can type them in the Q&A, and then Dave will be picking them up along the way. And at the end, we'll go through that questionnaire so everybody can be cognizant of what's being asked, and hopefully the great answers we can provide you. All right, so let's talk about use cases. So here is kind of a little bit busy, so I'm going to go through this a little bit slow. These are the high-level use cases that you may come across in your environments. We've selected 3 or 4 of them to get into real-world customers that we've come across over the last 12 to 18 months. You may want to test a new application in the cloud and then move it to on-prem. We have a distinct scenario where we did that. We'll discuss that. You might want to test a new application on-prem and then move it to the cloud. You may want to take and migrate your dev test to the cloud, and then you're now in a hybrid cloud scenario. We ourselves actually have done that, and I'll describe that in a bit here. You may want to migrate everything to the cloud, and that's where that measuring comes into play. Like, okay, if I want to take everything I have on-prem today that's on Storewise, I can very easily replicate it, migrate it to the cloud, but what actual footprint do I need out there? So we'll show you how to measure and trend your workload to make sure you have the proper footprint when you get there day one. This is my favorite. You want to migrate to the cloud, and then you have an oh crap moment, and then you want to migrate back from the cloud. Very easy to do with Spectrum Virtualize. You may want to temporarily do DR to the cloud. You may have a scenario where your formal DR process is going to come into play, next fiscal year, but you have a gap in time, so you may be able to do temporary DR to cloud, which is very, very beneficial when you have that gap. We have a solution about that we'll describe in a few minutes. And then you might want to do permanent DR to cloud. You might do tape today. You tape out your stuff to Iron Mountain, something like that, goes off site, and then you have always a trick to try to restore yourselves wherever you may want to do that. In this case, you can actually replicate your data or your snapshots to the cloud, and they're immediately available for bringing online. Some of our customers actually do that and have it live restoration in the cloud, so anytime they have an issue, they're actually as of their latest snapshot. All right, so these are some of the high-level things just to get you thinking on how the solution may play within your environment. All right, so first one is SaaS provider Galileo. So this is actually a solution we created for ourselves way back in the day, and then productized under the Galileo banner. But it's a SaaS application like many things out there, like ServiceNow, Splunk. A lot of these applications are now SaaS offerings in the cloud. So how do you migrate? So we had a scenario where Galileo was on-prem in a hosted data center in the Northeast, and we did our analysis, and it actually made sense for us financially and technically to move our entire SaaS offering from an on-prem solution to AWS. I was quite surprised by that, but hey, the data is the data. We were currently residing on a V7000, and we were actually doing this just prior to GA last year. So we, instead of having this great capability, which would have really given us exponential benefits by being able to replicate our snapshots, which we were doing every day anyway, move it to the cloud, because we always needed a constant refresh of our data during our testing phase. So we got stuck having to use AWS Snowball to move our data once a week and once every 2 weeks. And let me tell you how much fun that was. It actually works, so that surprised me, but it only worked half the time. Half the snowballs they sent us, we couldn't actually mount our data on, so we had to ship it back, get another one. Anyway, make a long story short, it would have been super beneficial for us to be able to move our data and our snapshots during our testing phase, and then of course at the very end to move us once and for all to the cloud. But again, if you have an application on-prem and you want to move it to the cloud, this is a great solution to be able to do that. Just pick up an application and move it. All right, we have a large federal commerce customer. They had a need from the storage group's perspective, which is kind of interesting. Basically on the compute side, on the application side, internally, they had been talking quite a bit about moving applications to the cloud. We were engaged in some of those conversations. They had a lot of things they need to solve first, which was data. Can this piece of data actually go to the cloud from a Title 26 perspective? So once they kind of solved that, the storage group wanted to be positioned to be able to move the data at the whim, and believe it or not, of the application folks. Hey, the application folks say, hey, our data is good, and let's move it to the cloud. The storage group really wanted to have the ability to allow the infrastructure to move some data, pieces of data, an application at a time. So this came at a perfect time for them last year when it went GA in June of 19. So as I mentioned, we were in the beta program, so we're able to basically go through an entire demo with the customer to show them how the solution worked. One, so they could see it, and two, more importantly, that it actually works. So now they're actively testing this, and as Michelle mentioned in the beginning, they're in the GovCloud, so obviously they couldn't go to the public marketplace. So this solution is available in GovCloud, I think soon to be in FedRAMP. So this particular customer is now testing their data. So again, they now have the ability, from a storage group's perspective, this was a gold mine for them because they wanted to have the ability to move things when asked versus doing some backups and shipping tapes, which would have been a nightmare. So now they have the ability to migrate any application all the way down to the LUN-based for any application that the business or the application folks decide they want to do that. So it's a huge benefit for these folks in order to do that. All right, so how about I want to test a new application in the cloud and move it to on-prem? Well, why would you want to do that? Well, this particular customer knew that the sensitive data that would be housed in this application ultimately could only live on-prem. So as I mentioned earlier, so we do have an AWS practice. So we're engaged with this customer and they want to go buy a solution in on-prem. And we're like, well, wait a minute, how do you know how big it needs to be? And they're like, well, we really don't know. I said, all right, how about we do this? How about we spin up something in their case, it was Azure, and be able to go test the application so you understand what the compute, storage, speeds and feeds need to be at a fraction of the cost. And then you can move the application back to on-prem if you need to do that, which always was their intent. So again, we were able to test them in the cloud, size it appropriately, and then once they decided at the end of the testing period, they're able to reduce their overall spend by over 50% for their on-prem footprint. Now, in their case, they had test data in the cloud, which they were able to replicate back on-prem. And then obviously, once they were going to go live, they have some secure data that couldn't be in the cloud, so they just replaced the data back there. But again, if you want to be able to test something in the cloud, super easy, super fast, you can scale up, size your initial footprints, and then you know exactly what you need to purchase for an on-prem solution instead of oversizing or many times undersizing an application. So in this case, it worked perfectly for this customer. Next one, this is a DR solution, as I mentioned. So this particular customer, it's a large spectrum scale customer, 2.2 petabyte cluster. They have V7000s on-prem, quite a few of them. And they knew they were going to start a second data center in the Northeast, but that was a fiscal 2021 proposition. So they knew they had a gap. So we were using Spectrum Protect to back them up, send them the tape, tapes goes off site. But they realized that for that amount of data, it would take quite a while for them to come up and be live for their customers who were actually accessing their data that they were housing within the scale grid. So we came up with a solution where they were able to replicate their data to AWS and fill a 12 to 18 month gap before they're able to actually do what they really want to do in fiscal 2021. So it gave them a really good solution to be able to get their data to the cloud. And it was kind of unique in a sense where they're able to have folders in AWS, and the users of this data were actually able to simply mount the folder from AWS and use their quote unquote case data locally on their desktops. So there was no such thing as a restore per se, but individual users were able to use that data directly from AWS, which is very unique for these folks. So it was a great success for them, again, being able to fill a 12 to 18 month gap in business continuity, knowing they were going to go to a true site-to-site replication for on-prem solution. But again, another option that you can do. All right, so let's jump into some technical things. So we talked about data reduction and a lot of the feature functionality we all know about Spectrum Virtualize for on-prem. So data reduction can come in the form of thin provisioning, compression, deduplication. So we went through an exercise to one, see how it works, and then understand the potential savings. Now, obviously, we always say your mileage may vary, but again, we want to actually go through this exercise ourselves and then be able to present to folks like you, because these are things that I'm sure you're interested in if you want to move your data to the cloud. Like, what benefits can you have other than these use cases? All right, so what would we say the problem is? The problem would be native EBS storage is thick volumes for all intents and purposes. The volumes don't do thin provisioning, compression, deduplication, etc. So all the volumes presented to your hosts are fully allocated, may waste capacity. All right, so what would the solution be? Let's use Spectrum Virtualize to take those quote unquote thick volumes and apply data reduction techniques to it to at the end of the day, overall save on your EBS costs. So let's go through our little exercise. Again, any questions you have throughout this, type them in the Q&A and we'll get to them towards the tail end. All right, so what do we do? So we stood up, we actually have an instance set up in Amazon, in our portfolio in Amazon, and our innovation center here in Malvern, Pennsylvania. So we always have things going back and forth for testing purposes, beta programs, customer testing. Customers love to be able to test things like this. It sounds too good. Is it really? So we do quite a bit of testing for our customers so they can really understand how this may work for them. So in this example, we created a terabyte volume, filled it up with real live data from our Galileo application, filled it almost all the way up, 982 gig. And you can see on the right, there's the Windows disk. Basically, then we took and imported that volume via image mode into Spectrum Virtualize, created a compressed copy, let it go compress, and then we're left with the compressed copy, which now resides exclusively in Spectrum Virtualize in AWS. All right. So here you can see after the compression, again, your mileage may vary, of course, and our savings is actually based on 2-to-1 compression savings. In this case, you can see we actually achieved a 6.4-to-1 reduction from that 900 and some odd terabytes down. So again, your mileage may vary, but this all works just like we all have known forever on-prem solutions with compression. And as I mentioned earlier, so deduplication is available as well, so that can even reduce your footprint or your capacity needs even more. So this here's for you command line folks, because I know some of them myself. Here's the command line output, taking the 982 gig down to 153 gig. That gives you your 6.4-to-1 data reduction. Again, so we're just taking normal things we've done in Spectrum Virtualize over time, applied it to our Spectrum Virtualize and public cloud instance, and just simply deploying things we've done for years. All right, let's talk about easy tier. All right, so what's the quote unquote problem? The problem would be within AWS, you have to select a volume type, but whether it's flash, spinning disk, whatever it may be, based on performance. So many times you're left with buying more capacity than you need in order to get the performance that you need. So what's the solution? Well, let's use Spectrum Virtualize Easy Tier functionality, which I'm sure many of you folks use in your on-prem solutions to optimize the data placement and potentially save costs. And we'll talk about what kind of savings you can achieve from an Amazon storage, quote unquote, footprint. All right, so what do we do? So here we go. We selected some GP2 storage, and we just have, we call it our middle tier. So we placed our data in that tier, and you can see from here, from the tier composition, there's a lot of active and inactive data on that particular volume. Okay, so then what we did is we went and we grabbed, we did some performance just based on that particular volume. And you can notice that GP2 volume comes with 1,536 IOPS. That's how it's provisioned. So we're theoretically gated at 1,536 IOPS for a 512 gig volume. Well, what if you needed 2,000, 3,000, 5,000 IOPS against that? You're kind of stuck. You need to go buy more capacity, even though you don't need the capacity for the IOPS that your application demands. This was actually kind of cool. So you can see we did our workload, measuring it. We talked about measuring. So our volume's actually achieving over 2,000 IOPS consistently. So what is that? Whereas the GBS volume, GP2 volume only can give us 1,500. This is the SVC, or the Spectrum Virtualized Cache enhancement. So you're actually getting 23% more IOPS on a GP2 volume than you normally would, simply by the cache in the storewise footprint. So that's already a 23% gain, and we haven't even tiered a thing yet. Okay, let's move on. So here, service time. Service time is very important. Wow, I get 2,000 IOPS. Well, what's my service times? So here you can see on the left-hand side is your read service times. Getting 4 mils. That's so-so. I'd be a little skeptical, like, why am I getting that? We'll talk about that in a second. And on the right-hand side, we're getting write service time 0.5. I think we all love 0.5 mils. That's mainly because all writes are going to cache. So we looked into that, and the 4 mils is because we're actually bouncing up against the 1,500 IOPS of the actual volume underneath storewise. So in this case, we're hitting that threshold. So how does Amazon or anybody basically throttle you? Once they throttle you, that means they have to increase the latency to the volume in order to throttle your throughput. So instead of having maybe 1 or 2 millisecond response times, I'm getting 4 mils. That may not be an issue for your application, but many applications have an issue when you're running that hot. So again, that's because of the volume being throttled. All right, so what's next? So we went and grabbed an IO1 volume, throw it in a pool. We took an ST volume, throw it in the pool. Now I have a 3-tier pool, and the IO volumes provisioned at 3,000 IOPS, as you can see here in the bottom right. We could have increased the IO volume at much higher, but for this demo, we want to show you what it would look at 3,000 IOPS. All right, so over a couple days, we let Spectrum Virtualize do its magic, move things up and down. And you saw in the middle tier previously, all the data was there, both your active and your inactive. So after a few days, you can see all the active data was moved up to your tier 0 flash from a Spectrum Virtualize naming nomenclature. And the middle tier has a little bit of active large data and all your inactive. And then your nearline tier is now filled with your inactive data. Okay, what does that really mean at the end of the day, right? So let's go look at performance again. So on the top left, here's your pooled tier usage. So instead of everything being in that middle tier, you can now see the various colors over here on your left-hand side of the activity or percentage of tiers, tier 0, tier 1, tier nearline. And more importantly, on the bottom right, you have your cluster service time. So we just talked about the 4 millisecond response time because we're being throttled at 1,500. Once I basically took off that governor, you can see that my service times dropped in half, or a little more than half, to less than 2 milliseconds. And then your write service times did not change. That's mainly because we're all writing to cache anyway, and cache wasn't being filled. So I'm still achieving the great 0.5 mils on my writes. All right. And just as importantly as service times going down is performance going up. So here, that 2,000 governor that we hit, which was the extra 23% on top of the 1,500 from the cache, we're now able to achieve 4,000 IOPS on that particular volume. And as we mentioned, the Spectrum Virtualized Cache enhances our capability to go above the provision workload. All right, that's the same thing we're just showing you. Now let's go into IOPS pooling. This was something really interesting, and you guys have been probably looking at a bunch of virtual sessions, so I want to try to bring in a little bit of levity into this one. So we literally tripped over this example as we're going through our testing. So what's the problem? So the problem might be GB2 volumes are throttled based on the size of the volume, as we mentioned. And what would the solution be? With Spectrum Virtualize, I'm able to take volumes, stick them in a pool, as we all know from an on-prem things we've been doing for years, and be able to achieve higher IOPS by the pooling mechanism. So let's go through a scenario of how that works. All right, so we have our 500 gig, 1500 IOP provision volume. And then we have another one at 1500 IOPS. And here's a little link. If you download the presentation, you can look at the EBS volume types and whatnot. And then what we did is we said, all right, let's go grab 2 additional volumes, GB2 volumes, and have them provisioned at 16,000 IOPS apiece. So in this case, it was 2 a little over 5 terabyte volumes that we threw in the same pool that we had the original 500 gig, 1500 IOP volume that we're being throttled on. So here you go. So disk 1 is the green guy down the bottom, and disk 3 is the red guy. So the 500 gig volume is the original native EBS volume, and the red disk, disk 3, is the pooled disk, or the V disk from the pool of those 2 larger volumes that we put in there. Now you notice down on the bottom here, the green guy actually went up above 1500 IOPS for a period of time and came back down. And for you, those folks that know about burst credits, within Amazon, you have burst credits that you can actually go above your purchased IOPS for a period of time until you exhaust them, and then you go back down. So that's exactly what we did here, is we were able to go above 1500 for a period of time, exhaust our burst credits, and come back down. All right, next. So the total IOPS I was able to do was, here's my read transfers, my write transfers for during the burst credit period. I was able to achieve 3,000 IOPS versus that straight line 2,000 IOPS that we were getting earlier. All right, and then once we depleted those burst credits on the native EBS volume, we were back down to 1,500 IOPS for those transfers. All right, so then how does that work with the Spectrum Virtualize pooling? So in this case, the red disk 3 is now able to achieve over 10,000 IOPS, same workload, because now I'm in a pool of volumes from EBS storage in a Spectrum Virtualize storage pool, and I'm able to basically share all those IOPS. So that original workload that's getting throttled will now no longer be throttled. So I'm able to, quote unquote, borrow IOPS from the entire pool. And as we know from an on-prem solution, that's kind of how it works. I can have multiple tiers, all the cold stuff goes down, the little bit of flash or a decent amount of flash, wherever you may have, can now be used for all the actual work that you really need done for your fast IOPS to occur. This is the same concept from an Amazon perspective. Now, I don't have to over provision a server or 2 or 3 or 4. I can put them all behind Spectrum Virtualize, and now I'm gaining the benefit of having volumes hot at different times of the day. All right, so let's go from a quick summary over those couple of things. So from a data reduction perspective, again, we only did thin provisioning and compression in our particular example. We're able to save over 23% savings in your native AWS EBS storage, just from compression. Again, if you turn on deduplication, you would increase those savings over time. Again, your mileage may vary depending on your data. We all know that. But this, in this case, this is real live data. From an easy tier perspective, we're able to save over 45% savings from Spectrum Virtualize. So you're taking your native workload today that might be in AWS, putting it behind Spectrum Virtualize, and you can actually reduce your overall EBS storage footprint up to 45% saving. So we actually have a calculator that we created to go through the pricing between, okay, Spectrum Virtualize in AWS, I need to buy the EC2 instances for the nodes, I need a Quorum node, and then I need the EBS storage. You put all that together, cost X, right? But your native EBS storage can actually be cost you quite a bit more. Again, your miles may vary, but this was really interesting to us to be able to come to some kind of like calculator method to determine that, geez, in certain scenarios, this actually could be very, very beneficial for our customers. And we do some studies for our customers along this, and we'll talk about measuring in a second here. And then we talked about the IOPS pooling. So we don't have an exact percent savings because this is so unique depending on your applications. Would they benefit by being in a pool of other storage? Quite possibly, and that's again where measuring comes into play. And that could save you yet additional savings on top of the two above that we mentioned. All right, so we talked about measure. Let's talk about it. So measure twice, cut once. So I found this really cool graphic because whenever I'm doing woodworking of my own, I really stink at it. I don't know why. I measure 18 times, but I still can't cut. So in this case, it's really important to be able to measure twice, cut once. So you need to be able to accurately measure your current workload, whether it's the entire workload, a piece of your workload, whatever it may be, and then be able to trend that capacity and performance so you don't start off on the wrong foot by having either oversized, costing you too much, which we have a couple customers did it on their own, and they found, geez, I think it was over 70 grand a month they were paying that they didn't need because they weren't using it. All right, so how do we do that? So we can, any tool set you may want to use that collects Spectrum virtualized data, you want to be able to collect the throughput and the IOPS over a period of time to see what are your peaks for that particular application, that particular run, or the entire workload if it may be you're moving the entire workload to the cloud. Then you want to be able to trend that. Okay, so you can take your 6 months, your 12 months, your 3 months, whatever workload that makes sense to move to the cloud, and whatever previous workload is representative of that. It could be like the last month. It could be the month of March. It could be year end, quarter end, whatever it may be. Take that input, trend that over time to figure out, okay, if you want to size your environment for day 1 or day 6 months or 12 months, you can be able to trend your application data performance, both capacity and performance, excuse me, for your throughput, your IOPS, and your capacity. Then you're able to start off on the right foot and not oversubscribe yourselves and pay, thousands of dollars a month extra on things you don't need. So it's very easy to do. Pricing scenarios. So just give you an idea, because a lot of you folks are like us, like, oh, geez, well, what does it cost? Is it like $5 a month, or is it 500,000 bucks a month? Most customers have very little clue on how much cloud actually costs until you go look into it. So in our case, we're able to measure it. So now you know exactly what you need to go price, and then you go price it. So in this case, we're going to show you a couple examples. If I have a migration to the cloud, whether it's a portion of your environment or your entire environment, that would be high performance. If you have, say, tiered performance, where you do have some hot stuff, some cold stuff, that would be something less. And then if you have like DR to the cloud, where you're good with slow performance because it's just a disaster recovery, and then you can always elevate that to higher if you have a true disaster. So we'll give you 3 examples from a pricing perspective. So in this example, we use 256 terabytes of capacity is the capacity that we needed. So here is all-encompassing for this particular thing. Includes the compute for Spectrum Virtualize, the EBS storage for Spectrum Virtualize, and the Spectrum Virtualize software licensing that Michelle had mentioned up front. So if you want to move your entire 256 terabytes of capacity for high performance to AWS, it gives you an idea on your on-demand would be roughly 34.4, and if you want with reserved instances for your compute, you can slightly save down slightly below 34 grand. So about 34 grand a month to move 256 terabytes of high performance workload to AWS. Next would be more of a tiered solution. So same thing, 256 terabytes. Here's your different EC2 instances here in the middle. Your licensing is the software licensing would be the same because it's the same capacity. And your net cost would be set a little over 17 grand. So just about half of what it would be for high performance. So again, this would be your mid-tier performance for your hot and cold volumes. and your EC2 instances are slightly less, your software licensing about the same. And the last one, from a DR pricing perspective, this would be quote unquote slower storage because you don't need it unless you have a true disaster, which you can then elevate. And this further reduces your cost down to about 11 grand a month. Same 256 terabytes, all in colder storage, SC1 storage in AWS, reducing your overall footprint. So I can protect 256 terabytes of capacity in AWS with Spectrum Virtualize for only 11 grand a month. This is that one solution I mentioned to you earlier. They're able to put 2.2 petabytes of their data up in AWS. And I think that was, what's that extrapolated out to be, about 40 grand a month, I think they were paying. So that was well worth it to them while they had that gap in time. So again, the goal of these couple things were to kind of go through, to give you an idea on what the cost may be for Spectrum Virtualize in AWS. We do similar things for just plain vanilla AWS. We're able to take performance statistics from your Linux, your Windows environment, your VMware environment, and size what an Amazon or an Azure solution may look like. Because again, most customers really don't know. So it's pretty easy to do that. So if you ever need, just give us a ring. We're able to help you out on that. Next one. If you need any help, this is kind of what we do for a living. So we have a couple offerings if you guys ever have a need or just want to chat about it. Some SaaS offer. You just want to purchase a SaaS offering of this Spectrum Virtualize in public cloud. We can actually offer you the entire whole thing as a service. Or if you just want some implementation help to get you going, to get you migrated up into AWS with Spectrum Virtualize, certainly can help you with that. And if you wanted to be MSP, we can certainly help you out with managed services of that footprint as well. Or if you just want to chat about, hey, how does it work? What are some of the gotchas? Just give us a ring. Love to talk to you about it. So we're about 10 minutes prior to our end. Hopefully you guys and gals enjoyed this. Some of the levity you tried to place in there, because I know you're going death by PowerPoint in these virtual sessions. So I want to turn it over to Dave and take on some questions that you may have gotten so far, or some that might be coming in now. So you might have any questions, just pop them in the Q&A. We'll be glad to answer them.